All right, turn the page. You see a bunch of graphs. Got a bunch of graphs here. All right. So what we're going to do is determine the domain and range.
X and Y.
Okay. So for graph number 1 here, we're going to look at domain and range. Domain is your left to right. Range is your up and down. Okay. So domain would be what? X, and your range is Y. Okay. So what about this one? What kind of domain does this have? Does it touch negative numbers over here? The X's for X values, does it have values over here?
Yes.
Yes. Does it have values over in here?
Yes.
If I plugged in values over here, would it still give me an answer?
Yes.
It would. It would just be off our graph, right? So the domain is all real numbers. Okay. Now, what about our range? Our range is up and down, right? You always start from the bottom and go up. So does it have values down here?
Yes.
Yes. Where does it stop having values at?
At 5.
At 5. Because we talked about this last week, right? And it could get really close to a number, but never actually touch it. It was a horizontal asymptote, right? And it actually has a horizontal asymptote at 5, which means the Y values will be Y is greater than or less than 5.
Less than 5.
Less than 5. So you got less than 5. Any questions on that? Okay. What about graph number 2? What's the domain of this one? Does it have negative values for X? Does it have positive values for X?
Yeah.
If I plug in an 8, will it ever get there? It'll just be way off our graph, right? Okay, so the domain is what? All real numbers. Now, what about our range?
Y is greater than 2.
Y is greater than 2. So, by the way, you notice, why am I putting a Y and then a line and then Y is greater than 2? Y equals.
You're saying the range is the same as Y, and then Y is.
The range is in terms of Y, and then Y is just greater than 2. That's all we're saying there. Okay. So what about graph number 3? What's our domain? All real numbers. And then our range. Less than -3. Good. Now you do 4, and then we'll go over it. So do number 4, then we'll go over it.
Right. So
Maybe.
Asks, yes.
What's our domain here? All real numbers. What's our range? Greater than 0. Y is greater than 0. Okay. Any questions on how we got that? Okay, turn the page. Now, we're dealing with solving exponential equations by graphing. And it tells us we're dealing with depreciation. Have we talked about depreciation before?
Yes.
We have. And it says vehicles depreciate value over time, meaning their value decreases over time. This decrease can often be represented by an exponential decay function. A construction company bought a new bulldozer for $125,000. The bulldozer depreciates exponentially, and after 2 years, the value of the bulldozer is $80,000. Now, what it doesn't give us here, but I'm going to go ahead and give you, is our function. Y equals 125,000 times 0.8 to the x. Okay. Now look at 0. What's our value for 0? 125,000. How did you get that? It's what they bought it for, right? That's what it started at. Okay. And then what about 2.5? How can we find that value?
Plug it in.
Plug it in. So 125,000 times 0.8 to the what power? 2.5. And that is what?
71,554.
71,554. We're not going to deal with the pennies because if you're dealing with a bulldozer, you're not caring about the pennies. Okay,
You lost a lot of money.
you did lose a lot of money, right? Why did it lose so much money after just 2.5 years?
Because of the use.
The use. If you're dealing with a bulldozer, you're driving it through the mud. Might have sunk it up in a mud hole once or twice. Might have pushed something down that you shouldn't have, and it might have broke a little something, and you just rigged it up to get you through the day. So I'll fix it right later, right? It happens. 90% of the time it happens, right? So it depreciates value, right? So what about after 5 years?
Plug it in.
Plug it in. Now I don't want to type it all in again, so I'm gonna hit second and enter. And it types it all in for me again. And then I change the 2.5 to a 5 and delete the rest.
This thing's gonna be cost like $5 by the end of it.
$5. You think so?
I'd buy it. It's gonna be worth less than that.
Right now it's at 40,000 after 5 years. Ooh, why can't it get to 0?
It's one of those that we've been doing.
One of those that we've been doing. All right, so what about after 7 years? Don't tell me, you figure out the rest of these values. Fill in your table that you got there. Equation, oh, we got covered it up. Let's take the equation here. 125,000 times 28 and raise it to the power. What's getting in? Okay. Hold on. All right, what value did you get for 7? 26,000 what? 214. What about 8.5 years? 18,757. What about after 10 years? 13,422. Round, right?
Did you round it?
Well, you said don't worry about the pennies.
Let's see. Second entry raised to the 10th. You round it to the nearest dollar. It's gonna round up, right? Round it up. All right, what about after 12.5 years? 683.
About time for a new bulldozer.
It is about time for a new
12
bulldozer.
and a half years.
It's 12.5 years old. It is time for a new one. So let's graph this. I'm not gonna graph every point. I'm just gonna start there. And then I'm gonna skip to 7 here. And after 7 years, how much is it worth? 26,214. So about right in here. And I am gonna jump back to about 5. What's it worth after 5 years? About 40,960. So about 41, which is gonna be about right in there somewhere. And then I'm just gonna sketch it.
Yeah.
Okay. Now it says the company wants to sell the bulldozer and get at least $25,000 from the sale. Use the graph to estimate the amount of time the company has to achieve this goal.
Well, we already did.
And when was it?
7 years.
About 7 years. So you want to really sell it before the 7 years, right? Because you want at least 25,000. So you want to make a little bit of profit, right?
7 years would be 26,000.
And you want to make a little bit of profit, right?
$1,000.
So you want a little extra money in your pocket. So you want to sell it before 7 years, around that 7-year mark.
But if they at least want $25,000, they still lost $100,000.
Yeah. So what are you gonna do then? You're gonna take that 25,000 and do what?
Put it in the bank.
Invested.
Put a loan down to buy a new bulldozer. Because you gotta have so much down to buy a new dozer, that 25,000 will cover that loan. That's how it is, how it works. Okay, then it says estimate when the bulldozer will be worth 50,000. When will it be 50,000?
About 4 years.
Well, 4 years. I want to find it a little more exact. So I'm gonna go in and graph it. So y equals 125,000 times 0.8 to the x. And then I'm gonna graph. Ooh, what's wrong with this? My window. My window's not right. So I'm gonna put in x minimum 0. X maximum is gonna be about 15. And then x minimum, y minimum is 0. Y maximum is, it's actually, yeah, we'll say 175,000. And then y scale, what's the scale of y going up by? What? 25,000. And then now I can go and graph it. And now it actually shows up perfectly, right? Does it look a lot like our graph? It does. So now I'm going to hit trace and find where my y is 50,000. Ooh, right there, 50,171.
4 years.
About 4 years. So squiggly line, 4 years. What does the squiggly line mean?
Almost.
Almost, approximately, about, means we're right about 4 years. When is it worth $10,000?
About 11 years.
About 11 years. Let's find out. So go all the way down, trace it down to really close. Ooh, right there. So about 11.36. So we're gonna say about 11 years. When will the bulldozer, I can't see that. When will the bulldozer be worth $0?
Never.
Never. Even when it's not running and it's just set there for like 5 years,
Somebody still buy it,
somebody'd still buy it for something.
even if
Metal
they
or
only
something,
$5.
ain't it?
Antique, wait till it's an antique and it sells for like
Could wait till it's an antique.
30,000.
But what
that'll
about
be like
before it's an antique? You can haul it off for scrap metal, right?
Mhm.
It'll still be worth something. And because it's a what? A horizontal asymptote, right? Horizontal asymptote. You don't remember when we learned about that with the magician? We have the problem with the magician where he cuts the rope in half and he cuts the rope in half again and again and
And I
again.
never really used it.
And it's-
Or the,
I'm
2 weeks
back.
ago.
or the frog
back.
that was like jumping on the desk. and
Wherever.
I'm too back to the method.
All right. So now, don't get out your Chromebooks
Why not?
because you're
Well,
gonna watch me.
I'm better for it.
Now, what is the domain of this exponential function?
All roll numbers.
So.
All real numbers. Submit. What is the range?
Greater than 0.
Greater than 0. Now, why is it not greater than or equal to 0?
Because they'll never equal
It's
zero.
never equal 0. So there you go.
That's our
Your
assignment.
release, that is your assignment. All you gotta do today, this is x.3 and get it to an 80.